Thank you. Good evening, everyone. This is the Victoria Centre Astro Cafe for October 20th. I'm Chris Pearce. I'm tonight's host. Currently, I have the following people lined up to speak. Natasha wanted to bring something to our attention. We have Phil Stooke. Did I say that right? Stooke.
Yes.
Yeah. Here, who's giving a presentation. Randy has some items for us. Dave Payne has a picture for us. Chris Gainor has announcements about NASA, and then there may be other announcements. So that leaves us with a fairly full agenda. So I'm not sure if we'll get to everything tonight, but we'll do our best. So Natasha, are you ready for your bit?
Thanks, Reg. I think because it's a pretty full agenda, why don't I go a bit later?
Okay, so maybe we'll start with Phil then. Thank you, Natasha.
Oh, okay.
You're up. So
I'm Phil's tech, so let's just get this.
Yeah, Randy is sharing Phil's presentation.
Doing it.
Oh, we're going.
Google Maps. There you go. Okay, thank you. Use those arrows.
Yeah. Okay, so I'm actually recycling a talk here. Did this at the end of 2022 at a NASA workshop on Apollo 17, and I'm just taking the opportunity to recycle it here. This is an illustration of one of the maps I'll be talking about, and it's part of my current project, which is revising my old moon book and preparing it for a new project, a new release, which I'll talk about more in the future. We're going to be looking at the Apollo 17 rover traverses. And I should say that I've actually done this for all of the Apollo missions, but especially for the last 3 that had the rovers. So let's. Oh yes, I'm doing right. Here we are. This is a map that was made by the Defense Mapping Agency, which had the NASA mapping contract during Apollo, and this was published in 1975. And it shows what people thought about the path that the rovers were driven on the moon. But the positions that are shown here were never anything but sort of educated guesses. There was no actual tracking of the drives as they happened. We got occasional readings of the location, but that was it. These lines are rough, they're approximate, sometimes they're very poorly known. And in fact, what we find when we track them better is that some of them were several hundred meters out where they were supposed to be. So there were substantial uncertainties in these things. And the reason that they weren't very good is just that the orbital images weren't as good as the things that we're accustomed to today from Lunar Reconnaissance Orbiter. Apollo had a fantastic camera, the panoramic camera that the last 3 missions carried, and the pictures looked great. They were good, but they're not as good as what we're used to today. And in particular, they could not resolve the tracks that the rovers left. So you couldn't see where the rovers had actually been. So let's have a look. Now this is a Lunar Reconnaissance Orbiter image. It does show tracks, but even with these fantastic images, you only get to see the tracks in some areas. You always get to see them very clearly around the lunar module in the little dark spot with a bright interior. In the middle of that picture, which is below the middle, is the lunar module for Apollo 17. There are tracks all around it. Some are footprints and some are rover tracks. But wherever they walked, the astronaut footprints are fairly visible. But rover tracks are only visible in certain places, and they're always around the lunar module is one of them. because the surface around the lunar module was brightened a bit by the rocket exhaust as they landed, and then disturbed again to make a darker track. But when you get away from that zone, it's much harder to spot these things. So you can't even use the LRO images on their own for mapping in many places. So what we're going to do instead is use these pictures. I'm talking about Apollo 17, but let's just be a little bit more general first. The first 3 landed missions didn't have rovers. The astronauts just walked. Apollo 11, 12, and 14. They just walked. And their footprint tracks are readily visible in almost all areas. So they're not a problem. But for the rovers, it was different. They were going to be driving long distances. And what they planned to do was to have a video camera mounted on the rover that would take pictures. It wasn't really live video, but it was a picture every 10 seconds or so, automatically taking pictures throughout the run. For Apollo 15, it jammed. It didn't work except in a couple of very small areas. We just got a little bit from Apollo 15, which makes it difficult to map. But with extreme contrast enhancement in the images and sometimes little other tricks that we can play, you can get a sense of where the tracks were. But Apollo 15 is difficult. With Apollo 16, because it's a different place, the rover tracks actually show up much more clearly in many areas, and it's only a few areas where you have to resort to other tricks. And Apollo 16 did carry the automatic camera, but as a backup, they had the lunar module pilot taking pictures every maybe 20 or 30 seconds along the drive as well. And what they did for Apollo 17, they decided that worked so well that they were not going to carry the automatic camera on the 17, and they just had the lunar module pilot, Jack Schmitt, taking pictures as they were driving. So here's one of the pictures that he took. And you can see there's some craters and things. Basically, if you want to know where the rover was when that picture was taken, then you're going to have to find out where the little features that you can see in the foreground actually are. It's still a bit tricky, but at any rate, that's what you can try to do. So
Do
let's
you
look
ever
at
get
an
to see
example.
stars? Or are they just in the sky? Do you ever see
Oh,
stars?
no. Because the settings are such that the ground is brightly illuminated.
Yeah.
So you've got an exposure set so that you can see the brightly illuminated foreground. You're never going to see anything in the sky except the Earth. Okay, so we'll look at an example of how this works now. So this is a picture that was taken at a place where, as they were driving along, they just stopped and scooped up sample off the side of the rover without getting off it, the LRV2 sample. And on this mission, there were quite a few spots like that. So they collected samples from more places than just where they stopped at the major science stations. So they're approaching it, and Jack Schmitt is looking for a place to collect the sample, and he says, "Can you get one on the rim of that crater?" And sure enough, if we look at that picture, although it's quite low contrast because we're driving down sun, the sun is behind the rover, so it's casting shadows in front of it, and you don't get very good visibility for driving under those conditions. But he's looking at it and saying, "Can you get on the rim of that crater?" So he wants to pick up his sample on the rim of one of these craters that we can see rather subtly there. Now, that is low contrast. So if we want to try to find where that is, it would help if we could crank up the contrast, obviously. So that's one thing you can do. The other thing I like to do is to make a rough perspective projection of that. Basically, when you look at the surface like that, the foreground is large and features that are further away are getting smaller and smaller. But you could project that out so that the foreground is shrunk and the areas further away are expanded in a perspective projection, so that it's a bit easier to compare with an orbital image. And of course, then the other thing is that you want to orient it so that it's going to be in roughly the same orientation as the orbital image, and then it's easier to match up. So That's the processed image. The contrast has been stretched. I've cut off the mountains because they're not helping us there. But we can see that there are a few craters nearby. And the more you look, the more you can see of a little cluster of craters there. So the question then is, where is that? Right? Basically, all you have to do is find that in an image, which is not the easiest thing in the world, but here it is. So I labeled some of these craters. A and B are larger craters there. B is mostly cut off by the side of the image. C is a little one in the middle. D is just a bit beyond A, and there is actually faintly visible. There's one beyond D and a bit above it, which shows up in that image too. Anyway, basically, you can find it if you spend a lot of time looking for it. You can find it, and of course, once you've found one, then of course the next one will not be too far away, and so that narrows it down a bit. And it's not actually too bad matching these things up. Obviously, it's not.
Excuse me.
Not easy. Yeah.
Where were you? In this, is it with NASA?
No, at my university,
Okay.
University of Western Ontario, and some of that was done here as well.
Okay.
After I moved here. So anyway, here's an LRO image here where I've marked the positions of some of those images, and so you can see that you can start to track down the path that the rover has followed through that area.
And you don't have any track there? Is that one of the places that you...
Nothing is very certain, but let's just, since you mentioned that, let's look at that. This is the same image. It's enlarged a bit, and it's the contrast is cranked up very severely, and well, you can sort of see some things, but the problem with that is that actually the more you look at that, the more tracks you think you're seeing. They're all over the place. Some of them completely in the wrong orientation. Some of them in places that they never went to. So you can sometimes pick out tracks that match what I've been mapping by the previous method. Sometimes you can see that, but sometimes all sorts of other things show up as well. So it's confusing. It's not guaranteed to work, but sometimes you get a little bit of reinforcement for what you're doing that way. So this is just an example of one of them from the first EVA. The white line, there's a broad white line going up and down, which is taken from that older map, the 1975 map. On the screen, it's rather hard to see, but there is a fainter white line, which has a bright mask around it, which is the actual path that's been mapped out using the images in this way. So basically, you can get something here. This was a little bit more tricky than usual because in this case, when they were driving out from the lunar module to what they called Station 1, the first place they were going to stop and do science, Schmidt was, as I say in the text there, holding an explosive charge for the active seismic experiment. So the active seismic experiment was an array of geophones or seismic devices that would measure vibrations, and they set off explosive charges at different places around the landing site. So they didn't do any of this while they were on the ground, of course, but as they're driving around, every now and then they would leave an explosive charge at the pre-planned location. And then when they left the moon, they were set off one at a time. And the signals were recorded as they passed through the subsurface and then into the detectors so that they could map out the subsurface structure of the landing site. So he wasn't supposed to hold it on his lap, but he did. I think he was in a hurry. He picked it up, sat down, put on his seatbelt, and he held this thing. And that meant his hands weren't free to take pictures, which he had recognized was a bit of a problem. But That didn't help me anyway. But on the way back, you could take lots of pictures. So they were used to
Has
it.
that seismic survey been processed and?
Oh yeah, oh yeah.
Oh, yeah. Well, I'd love to see that.
Yeah, there would be a paper about that. The Apollo 17 active seismic experiment, which would show up in papers. So here, this is one of the pictures that Schmidt took on the way back. And it's been processed the way I described: contrast enhancement, perspective projection. And it shows tracks, and those are the tracks that they drove on the way down. Now they're driving back roughly along those tracks. So in some of the images on the way back, you actually get to see the other part of the drive. So we can fill in parts of that drive, even though we don't have the pictures. So when you have good pictures like that, it's really easy to map from the sides. Now I want to come to one of the most interesting areas of the whole mission from the point of view of trying to do this work. This was on EVA 2, the second EVA. They drove out about 10 kilometers, the maximum possible distance that they could go, to the foot of one of the mountains. And to get there, they had to cross a scarp, or a low rise in the ground, which we can see running kind of roughly diagonally, but from the bottom to the top there. It's called the Lee-Lincoln Scarp in that view. And as they drove out from the lunar module, coming from the right-hand side across the image, they reached that scarp, and they've got to get past it. And they didn't really think that they could just drive to it and straight up and over it. So they looked for a nice little gap somewhere where they could get through. They called it hole in the wall. So the old map, the one from 1975, is the white line that is shown on there. And it comes in from the right. Oh, I guess I can use this pointer, can't I? Okay, so it comes in there and then down, and they actually have it going right up the scarp and across and then down to the mountain. And then on the way back, they come up and supposedly up and then along the top of the ridge until they get to Station 3. That's not what happened. The thing that we have to help with this is that we have transcripts of the communications, so we know what they're saying. We've got all these pictures that Schmidt took along the way, and occasionally you get to see tracks. Okay, so this is the kind of a close-up. They're coming in right in the top right corner and moving to the left. Oh, where's my little? Oh, there we are. Okay, I managed to get a little box up there, which I didn't intend to have. Let's go back. Okay, never mind. Okay, just a minute. There. No. There we are. Okay, I was trying. All right. So anyway, they've come in at the top, and as they come towards the hole in the wall, they're heading straight for it. But Cernan looks in into the hole in the wall, this gap, and he says, "Oh, there's a long depression there." He says, "We can't get in there. I'm going to go over here," and he swings the rover around the left and loops around and then back and up a very low part of the scarp. And goes on, and then on the way back, again from the bottom of this, he doesn't go towards the scarp and then along the top of it, as the white line suggests. He actually drove right down and across quite a steep little hill down off the scarp onto the plains below, and then along the foot of the scarp and all the way out. The old maps were never set up correctly to fix that. Here we have EVA 3, and for most of the route, the maps are pretty good. But there's one area which can I point to it here? It's right here. So sort of middle right, where the actual path is about 300 meters away from the path down there. So were parts of EVA 2. They were about 300 or 400 meters away from where they thought they were. So let's have one more look at this. So this shows that area close up. They are coming in from station 8, which is at top right, and as they come down, instead of following the broad white line, which is where it shows they were on the old map, which came right down to the bottom of that image, they actually went across the middle of the image. There's a very shallow depression, which I've shown as a dashed circle, and they ran around the top of that and across the edge of it. It was a very shallow thing to get by it. So they're several hundred meters out anyway. So lots of uncertainty in the old maps, but now we're able to make this much less uncertain. Almost all of the problems that we had are corrected with these maps now. And I just got a little thing about here about where you can see these if you want to. So the maps that I made were used by the LRO team on their website. And what they've done is to produce a set of maps of these for every Apollo mission that shows where they were. It's tied into the transcript. So it's a screen grab on the lower right there. You've got a map. It shows the path that's being followed, and they have a little symbol that moves along to say, this is where they are at that particular time. It's tied to the transcript, which is playing in a box underneath. It's linked to the images, which are on the right-hand side. You can click on them and enlarge them, that sort of thing. So this is on a part of the LRO website called Featured Lunar Sites. And I've provided an LRO there, and they have just redesigned things and changed that. And I haven't corrected it here. But if you were to Google just LRO Featured Lunar Sites, it would take you to the new one. And they have these for all sorts of missions, but especially the Apollo ones are really good. Okay, so I just wanted to wrap up with a couple of extra things. One of the things they did with the rover, a process that was invented on Apollo 16, and they used it on Apollo 17. If they wanted to get a panoramic image of an area while they were driving, if they were stopped, they would just take a picture and then hop around and take a picture and so on all the way around. But if they were driving, they drove this rover in a tight circle with the LMP taking the pictures, and then you fit them together and you can make a panorama. So that's the top one there is a panorama of a place called Victory Crater on EVA 2. They didn't stop there for more than a few seconds to scoop up a sample and put down an explosive charge, but they did take a rover panorama like that. And the one below it shows where they set down an explosive charge during EVA 1 as well. And once you've got that, you can project it out into a map geometry. So the one on the left there is that panorama in the map geometry, and then there's been a few craters marked out on it to show where they were. So you can basically track down those locations very precisely from that. It's just one other thing I would really like to find at the Apollo 17 site, and so I'll just mention it to close this, and that is the place where the lunar module ascent stage was crashed. After they finished on the surface and they took off in the ascent stage, flew up to orbit, docked with the orbiting command module, and unloaded all their stuff. Now they didn't need that ascent stage anymore, and it was deliberately crashed to make a seismic signal. And they did this on all of the missions from Apollo 12 on. And for Apollo 12, 14, and 15, and although it doesn't mention it there, 16, because we discovered it more recently, we know where the ascent stage crashed. We can see the impact. but for 17, we still haven't found it.
You know kind of where it is.
Kind of where it is, but it hasn't been. We haven't got the splat on the surface. Haven't found that yet. So I'm still looking for that. And I think that is, yeah, that's the end of that. There we are. Yeah. Wow. And I should just say, all of the maps that I've made will be available in a publication. Well, I call it a publication. It will be a free download, which I'll have organized by the end of the year. And so I'll let you know.
I guess there's not a lot of landmarks to guide your driving, or every crater looks the same.
Well, that's true, but because that particular landing site, Apollo 15, was surrounded by mountains, there were always things on the horizon to help you all the way. So that wasn't too bad. Yeah, but in some places it would be very difficult.
Are there any questions from the participants on Zoom? Just raise your hand. Okay, seeing none. Anybody else in the room? Reg.
Oh yeah.
Really interesting, Phil. Thank you. You mentioned that the farthest that the rover could go from the, I guess, the lander was 10 kilometers.
Yes.
Could they see the lander from where they were, or did they?
Well, on that particular one, they couldn't because they were down in a dip. But in other places, when they were that far or nearly that far away, they could see the lander. It did stick out pretty well in the landscape. But I said that was about as far as they could go. And the reason is that if the rover failed, they would have to walk back, and the maximum possible time that they had to walk back dictated that they couldn't go further than 10 kilometers away. And also they would have to do that distant sight first in the EVA. So they drove all the way out there and did that, so they would still have time to walk back. And if it did, but it didn't break down, so they could drive back to other stations along the way. And if they're closer, so if they broke down later, they'd still be able to walk back from them. But yeah, they couldn't go further than that.
So they would have the tracks as breadcrumbs to find us.
Yeah, they would. That's right. That would help. Yeah. That's right.
Well, thank you very much, Phil. That's very interesting.
Yeah.
Look forward to hearing more if you come up with more.
We've got more.
Yeah.
It was fantastic.
Should we, Natasha, would you like to go next?
I'll go after the next person.
Oh, okay. So, Dave, do you want to show us a photo then? How about that?
Yeah.
And then we'll have Randy's trio of topics potentially.
Actually, Leslie, I would love to display today's front page Globe and Mail presentation about the Saskatchewan Star Party, but I should not be the one that talks about it. It should be you. First of all, do you know about it?
Mm-hmm. I didn't know about the article being published today, but I met the author and he said it would be published in coming months.
If I run the screen, will you talk to it?
I haven't seen it at all. So.
Well, this is going to be very exciting.
Okay, I can make comments.
Yeah.
Maybe you want to guide the overall presentation.
Yeah, we'll do it together.
Okay, so Dave, what have you got for us here?
So I got a picture of an object you've probably seen before.
Looks very pretty.
Is it up there? It's,
Yes, it is. Yeah.
Amazing.
It's the Orion Nebula. And it was taken with narrowband filters. And I did a little trick and took the brightness from the narrowband filters and then colored it with red, green, blue.
Oh.
So you kind of see what the Orion Nebula, which is really a star forming region, looks like in regular colors. So that's narrowband, and I'm just like, I stared at this quite a bit when I was processing it, and I finally came to a 3D visualization of what this is in my head. And I thought I would try to explain it very briefly because you're usually projecting this as a 2D image, of something, but it's really a 3D object.
Right.
And if I can try and do this for a second, if you can imagine the skull of an owl, the face of an owl, with this being its beak right here, where I've got this cursor, and its two eyes
Okay.
being on either side, and this is kind of the bridge of its nose, if you will.
Oh, okay.
Okay.
Okay, so it's kind of on its side, and there's no eyes in the socket. And what you see is a bent tube going into a cloud on this side and then out on the far side. So this
Really?
end is connected up to this end. And you're actually looking into this bent tube. And in the center of this tube, with a sort of a gas bridge overlying that tube, and you're looking inside the tube, and right here is where the center of the tube, where the new stars are rapidly being formed, and it's emitting all this UV radiation that's going out to the sides of the tubes, and that's sort of transforming molecular hydrogen into hydrogen ions and atomic hydrogen, and it's heating it up, and it's blowing out of either side of this tube and eroding the walls and making it wider and wider. And this little blob here is a different star forming. It's a star that's kind of blowing a little bubble into, it's separate from the two, it's blowing a little bubble of solar winds are blowing a little bubble into the hydrogen gas. But once you kind of see that 3D view, it's kind of hard to go back to the old 2D visualization of it. But so that's all I have to say. Hopefully that's interesting.
Right.
Yeah.
Cool.
So Dave, keep it up. Don't put it
Disappear.
away.
Oh, okay. I'll bring it back up.
You're totally
Cookies from
changing
reminds me from
what it looks like, but
when I was
so
a bird.
there must be some velocity structure when they do. Like, can they do spectroscopy on very tiny bits and see how they're moving radially?
So, sort of. If it's atomic hydrogen, you can see it with its 21 centimeter wavelength.
Mm-hmm.
If it's molecular hydrogen, and that's a spin flip of one of the electrons. If it's atomic hydrogen, you can't see it unless it's like room temperature or something. The only time you can see molecular hydrogen is in like a Herbig-Haro, where a star is throwing out warm hydrogen. But this is just too cold, you can't see it. And you can also can't see hydrogen ions. So although it's mostly hydrogen, most of the cases you can't see hydrogen. The one exception is when a UV hits a molecule, breaks the molecule, and leaves and pushes out its single electron. Then that hydrogen ion recaptures the electron, and then it emits what's pink and red and orange in this image.
Yeah, I was just thinking that your tube, the top part of it would be coming towards us, and the back part would be going away. But if you don't have a line, I guess, if it's a continuum, you can't do anything.
Yeah, I mean, if you could focus well enough. Well, the other thing you would like greatly,
I like every focus.
is if I put this. There's the moon.
Oh, no kidding.
Gives you a sense of the size of that nebula in the sky. So it's almost
Half a
the
degree.
hole is almost the same size as the moon.
Well done, Dave. Well done.
So it will swallow the moon if
I'm not
it
trying
gets
to
too
suck-
close.
I'm not trying to suck up to you, Randy.
No. It's huge. You don't realize how huge that is.
Yeah, you don't, kind of.
Yeah, that was going to be my question. Is do you know how wide that is actually there? Is that like light years across? Many?
Oh, yeah, I easily looked it up, but I can't remember. It is,
It's huge,
it,
though. Yeah.
it is the closest major star forming area to us.
Right. Okay.
And it is very bright. Relatively speaking, not compared to the moon, of course, but relatively speaking.
Yeah.
But on the other train of thought, just to cut a long story short, what you're really looking at is the interface between these types of gases, the ionic, the atomic, and the molecular gases. You see what's happening for the most part, you're seeing what's happening at the interfaces of those gases.
Very good.
Thanks. Any questions for him? No?
Wow. Very nice. Thank you. Okay, so
Thank you.
want to have a go, Randy?
Okay, so share, and just because we have Leslie here, we're going to do an experiment. I'm going to put on the Globe and Mail. Where'd it go? Here. So this is today's Globe and Mail, and I thought, oh boy, we're on the front page of the paper. So Fred Lum documented it, and why are they doing it 2 months later? I don't know. Anyway, this time lapse is just fantastic.
Did he say who did that?
He did.
He did. Okay.
Yeah,
Yeah. So
it's actually part of a series showing special events or relatively special events in each province. So the series has nothing to do with astronomy. It just happens that the Saskatchewan Star Party was featured in the item on Saskatchewan.
So go ahead, Leslie, if you've got stuff to say about the pictures.
Well, this is part of the telescope walk. I don't know who that is, but they're showing off their telescope. What does he say there?
It doesn't say who it is.
Okay, you may not have known either. That's the registration tent at night, which also serves as the red light cafe overnight.
So Donna Lee May.
Yes, that's she's one of the registrars. She's actually a companion to Rick Hudiak, if you know who that is.
Anyway, I just think it's beautifully done.
Oh, that's an unusual picture. Yeah, beautiful. If you
So you were there somewhere?
well, I'm actually just down below the right hand lower part of the image.
Okay.
If you go up, no, I'm further down than that.
Okay,
If you can
that's the bottom.
go a little bit more, I might appear.
No, that's the bottom.
That's it? Okay. Anyways, I'm off the. So this is called the Meadows Campground, and there's this large sort of open space. You can camp in the open, or you can camp around the periphery in the trees. And there are both camping sites for RVs and for tents. Oftentimes, people congregate in that open area, the green area on the right, because anybody can set their telescopes up there. And I have to say that, and I've been going for 20 years, and nobody has ever touched or bothered. You just leave your scopes there, and nobody ever touches. So
312 observers.
Yeah, that sounds right.
from Germany, England, New Zealand, and Australia.
What the heck is that? Oh, that's a trailer. I don't know who that is.
Somebody's
Okay.
observing shack,
Yes,
basically,
it
right?
is, basically, yeah. License plates, yeah.
Stargazer.
Stargazer would be more appropriate.
That's it.
One of those, yes.
That's the what obsession that is that, yeah, that's an obsession.
Sure.
The 20-inch obsession that Vance discovered the comet with in 1990, in 2001. Okay, that's good.
Roy Randine.
I know why. Okay.
Yeah, he's an Edmontonian. That's
Yep,
why
I
you
know
know.
right well. Yeah, there's lots of different scopes there, and people are very friendly, and you just wander around, and everyone will show you what they're looking at, unless they're imaging. Imagers are less friendly. They're more preoccupied.
Mhm.
That's a good mount. Just a little tire.
Yeah, I didn't see that one. That's interesting.
Low tech.
I think it's called a portable.
Yeah, that's right, portable, and it came,
Portable.
and it originally came with a crossed plywood that had that stuff on the corners so that you could roll it around however you wanted.
Well, so those of you who remember Barb Wright, that was her granddaughter.
Oh,
Okay.
yeah, I like this quote. You might have a bad day or you're not feeling the greatest, and you can just point your telescope and all your problems go away. It's just so relaxing sitting in the solace of everything. I think a lot of us can relate to that. But it's great, and there it is in
Well,
major newspaper, front page.
But it's actually the articles on page A7 and 8.
Yeah.
It's all a really nice widespread.
Mhm.
Well done.
Yeah, lots of pictures, at least in the online article.
Yeah, no, they're all in the print too.
They are too.
Yeah.
Oh, well,
Just it's really nicely presented there. Okay,
thank you.
so thank you, Leslie. So Jeff, I had been avoiding even reading about Comet I3 Atlas until your presentation last Astro Cafe, because it kind of irritated me seeing people carry on about alien technology and such. But you really piqued my curiosity, and it turns out it's really cool, as you had brought up last time. And so I have in the can the third chapter of the book about Aldebaran, but we'll do that when there's not something exciting like the comet around. Okay, so I discovered on July 1st, it's this little crosshair here. Atlas is the asteroid terrestrial last alert system, something like that. Anyway, it's a set of telescopes. This one was in Chile that saw it, and they take pictures every day, and their goal is to see if something's going to go and whack the Earth with days or weeks advance. And so this one showed up, and you don't have to read this. We'll go through it, but this is kind of the outline of what I'm going to talk about. So let's, first of all, what is so important about it? The big thing is it has this hyperbolic orbit. And that sounds really fancy, but I mean, it's one of the coolest things about, what do you call it? About what's the word? Trajectories, how things move around in space, is they actually follow the shapes that you get when you cut a cone. I think it's absolutely bizarre. There's some fantastic math in it that Kepler worked out, and then Newton gave it a kind of a physical background with his universal law of gravity. But the important thing is everything that is in the solar system traces out a circle or ellipse with the sun at one of the foci, at the focus. And in order to be bound by the sun, it can't go too fast. But the faster an object goes, the more it moves down this kind of line until if it's going way too fast, then it's not going to stay in the solar system. It comes in, whips around the sun, and it goes out. And that is what 3I Atlas is doing. When they discovered it, a bit past the radius of Jupiter, it was going something like 60 kilometers a second with respect to the sun. So the fastest before was I2, Comet Borisov, and it was half that speed. And it's just like unlike anything else. The other thing that people are really surprised with is that it is pretty much traveling through the plane of the ecliptic, the plane that all of the planets are going around the sun. And, there's only been 3 that have ever been discovered. That's why this one's called I3. The first interstellar was called Oumuamua, and it had a steep trajectory, and then I2 Borisov had a steep trajectory. So this one is shallow. I mean, it doesn't. As somebody who does spherical statistics, if you have 3 objects and one of them happens to be in a direction that you think is privileged for some reason, that's not different than a random collection. But it is true that I3 Atlas is coming in very close to the orbits of the planets. Now, unfortunately, here is the Earth, in the middle is the sun, and this interstellar object decided to come on the far side of the sun rather than the near side. It was not very considerate.
Well, it depends.
It depends.
As long as it doesn't hit you.
Yeah.
Yeah.
Yeah. But we're going to talk about its size. It would be damaging. It wouldn't be catastrophic. But it does go very close to Mars, like 0.2 astronomical units, 0.2 of the distance of the Earth to the Sun from Mars, which is pretty cool. Okay, so the next thing is that every major telescope on Earth is looking at it. Incidentally, it's at around magnitude 11, so certainly you clever astrophotographers would be able to pick it up. Anyway, of course, it was first identified by Atlas, the asteroid terrestrial last alert system. But interestingly, Vera Rubin, which is still not operating, it's still in engineering stage, it caught 41 pictures of I3 Atlas before Atlas discovered it. It's called a pre-discovery or pre-covery, something like that. Anyway, it just happened to be pointing in the right direction and caught all these pictures. The best pictures are from the major telescopes on Earth, Gemini, the VLT, the Gran Telescopio in the Canaries. And then there's a bunch of space telescopes that have been seeing it, and the Mars things like the Mars Express and the ExoMars, and even Perseverance, which is the little rover on Mars, got a nice picture of it. Anyway, I'm not going to show a whole bunch of pictures, but this one is particularly nice. I like it because, you know, the way you take astrophotos is our own amateur astronomers do every time, is you take monochrome pictures with different filters. And so when you stack them together, the stars all look beautiful, different colors. You've got the cool red ones and the hot blue ones. But what you see with the comet going by is what happens to be the color of the filter at that time.
Ah, right.
So this is a whole bunch of pictures as the comet is moving along. And I think the picture at the very first of this deck was where you stack them all up for the comet, and then the stars look funny. Okay, the size. So one of the things that was considered extremely exotic was the first estimates had it up to like 20 kilometers in size, compared to like a kilometer or less with the other two. And the reason that that is a problem is whenever you talk about grain sizes or anything that is made by either gathering together or breaking apart, you expect a lot of small things for every big one. Okay, so there's a lot more sand grains on Earth than there are boulders. And so if you take 3 objects from the surface of the Earth and you got 2 sand grains and then a boulder, then you would say that's something funny. But the whole thing about these 3 things is that there's something funny about them. They did not form in a single system. They're from all over. And so for me, it doesn't seem at all surprising that they're not behaving as if they come from a single population. Anyway, the other thing is, as time goes on, the estimates for the size of the nucleus is getting smaller and smaller. One of the things that's important about it, we'll talk about that later on, is the constitution. So just bank that. So a thing that people found kind of crazy is that as well as the tail being swept away by the solar radiation, it had what some people were calling an antitail, but it is better to call it a sun-facing plume. And it actually is something that comets do, because what part of the comet is melting? The part that's towards the sun. And so you get particles coming towards the sun, and then they get swept away with the solar wind and go off behind, and that tends to be the big part. But especially when they were seeing this sort of sun-facing emission, it was very early on. Normal comets, normal solar system comets, you don't really see until maybe a couple of astronomical units away. And this one was out at like 4 or 5 astronomical units. And the thing is, it had a pretty big coma and this sun-facing emission because it's not mostly made out of water. Okay, most comets are made out of water. But the thing about Atlas is, except for one single comet, it has the highest ratio of carbon dioxide to water. And as you know, carbon dioxide makes dry ice, but it melts at a much lower temperature than ice. It is less stable, and so it doesn't take as much solar radiation to make it melt. Okay, and so there's all sorts of things about Atlas which are because it is mostly made of dry ice instead of water ice. Okay, but the other thing, and this is the one thing, Jeff, that you talked about that really got me and got me talking to my geochemistry colleagues, is that it had much more nickel than iron. And so the deal is, when stars do their nucleosynthesis thing, they iron happens to be the element that has the lowest energy per nucleon, or in other words, you can go from hydrogen to helium to, carbon, oxygen. You can keep getting bigger and bigger nuclei for those elements, but they won't go past iron. Iron is the most stable nucleus, and so there's quite a lot of iron in the universe from all of these dead stars, and nickel is just not as easy to make. So there's a lot less nickel in the universe than there's iron, and so it's very difficult to get nickel by itself. We on Earth, in Sudbury and the smelter and stuff, do it with high temperatures and pressures and fancy, very nasty chemicals, but it's not a natural process. And so they were saying, oh my goodness, this is not natural. Okay, so I love this. This paper was published on October 1st. I love it when I can present to you data of a paper that was done in the same month that I get to present it. Anyway, so what you have here is through time, as 3I Atlas is approaching the sun, and this is the ratio of nickel to iron. So it started off way over 10, and then it came to 8, and now it's going down and down. And the authors of this paper are saying that by the time it gets towards close to the sun, it's going to be just like any of the other what do you call them, comets that we know and love. So they say it's just because of the nickel coming off preferentially when it was far away. But what they are hypothesizing is that the nickel and iron are in the form of carbonyls. So what you see here is carbon monoxide, CO. Okay, and CO has this extra bond. Carbon has 4 electrons in its valence. Anybody remembers their high school chemistry? And that, so 3 are attached to the oxygen. They have 1 left over, and nickel has 4 hooks around it to hold on to these carbon monoxides, whereas iron has 5. And so nickel tetracarbonyl, which is a chemical they make on Earth, but again, it's very difficult to make. They use it in some industrial processes, but they make it at high temperature and at high pressures. But there is a condition out in the cold and the vacuum where there are some nickel particles and lots of carbon monoxide that you make these carbonyls. It's a natural process that can happen in interstellar space, and it turns out that nickel carbonyl is just a lot more stable than iron pentacarbonyl, just because the symmetry of a tetrahedron is better than a, what do you call it, a dipyramid.
So this is volatile. So that's what's getting rid of the nickel.
Yeah. Yep. Anyway, they were saying it's not something that alien technology had to produce.
So it's not a stainless steel spoon.
No, that's the problem. Anyway, I'm starting to really, really like Neil deGrasse Tyson. There was a while that I thought he was spending too much time trying to be cool and funny and not giving us enough science. But the more I find out about him, the more impressed I am. And he did this really good YouTube. And he started talking. So why is this important? There is a very famous and authoritative and capable astronomer at Harvard. He was the head of the department for a decade, and since the first interstellar comet came through, he's been making quite a name for himself by putting out lots of social media about how these interstellar comets are alien technology. And what Neil deGrasse Tyson talks about in this YouTube is how for millennia, when people got to the limit of what they understood, they would talk about the God of the gaps. Okay, that God has to be the solution because we understand everything, and what we don't understand had to be put there by the gods. And it's not just the Greeks who would say that. He gave a really good example of Newton writing about this in the Principia. And that could make its own really, really good Astro Cafe talk someday. Anyway, so Newton was very happy to say, I understand gravity. This doesn't work. Therefore, that must be God's intervention. And he, that was in 1700. That was acceptable. Anyway, sometime with the rise of science fiction, with the decline of religion, somehow we've moved from the God of the gaps to the alien of the gaps. And this is another case of it. Sure, there are weird things with this interstellar object. It did not grow from the population of everything else that we see in the solar system. It is exotic and so great. And so the answer is, of course, let's observe it. And that's why all of those telescopes are looking at it like crazy. Anyway, I thought that was just fantastic. Again, Jeff, I had been avoiding it. I have to say, I cannot watch another YouTube with Avi Loeb. He grates. His tone of voice, his way of presenting, I just can't handle. So I'm boycotting him. Yeah.
Margie had a question.
Oh, good. Margie.
Comments?
Margie?
Yes.
Comment.
You're on.
Yes. I asked, how do you know whether, you mentioned that it's on the far side of the sun. How do you know which is the far side and the near side?
Oh, just not the side that the Earth is on.
Oh,
My
gotcha.
definition.
Okay.
Making it extremely hard to see it from here, obviously, because it's in the day, right? I guess if it's even visible to us.
Yeah. I mean, it's gone now until it goes past. The other thing is, if it were on this side of the sun, we'd have a chance to see its coma. The best time to see a comet is when the sun is burning the stuff off it. And we're going to miss the closest approach. I think it's happened. Does anybody know? Anyway, it's just inconvenient, except there is going to be another chance. It's not just the things around Mars, but the spaceships on their way to Jupiter, the Europa Clipper and Juice, are both going to get a chance to take a look at it also. Because they're very clever. We put spaceships out there.
Closest to the sun on October the 30th.
Okay, so
thank you.
Not quite, but almost.
But I think it's not visible anymore to anything except for the things on Mars. And there, the problem is that the data that comes to Earth from NASA, amateurs can look at it, but the professionals can't because they're being furloughed right now.
So because the ejecta from the comet is actually preceding it on its orbit, it would have an anti-tail.
Well, I think what happens is that the anti-tail is a thing.
Is that an ejecta that's coming off?
Yeah, I think it's normal for comet ejecta to come off the front.
Yeah.
And sometimes, like with Neowise, like Caravallo's pictures, you can actually see a spiral around it.
Yeah.
Because it's spinning around and then it gets swept back.
Hello.
I've got a question for Phil. They mentioned that they took a photo of this object with the Perseverance Would you happen to know what sort of imagery or cameras they have on Perseverance?
Well, it's not going to be very impressive. Yeah, sort of kudos to them for trying, I guess, but it's not ideal. I mean, for one thing, you're looking through an atmosphere, whereas the orbiters are above that, Mars Express and so on. They have something that works as a kind of a telescopic lens when you're actually on the surface, but
No, it was the
highest
navigation.
resolution one can't be used that way.
It was their navigation camera,
Their
which
right,
was
which is
designed
low
for looking at the
resolution.
stars.
Yeah.
Perseverance, well, I mean, typically for a spacecraft traversing the solar system, the navigation camera, we might call it a star tracker, is for looking at stars, but the navigation cameras on the rovers, like Perseverance, are not. They're low resolution, wide angle, so they can't be used that way.
Okay, because what you
Then
see is a streak.
Yeah, so you get it. You might
from a 30-second exposure.
Yeah, you can take a long exposure, but it's not going to be terribly impressive.
It's impressive they could do it at all.
It is.
Yeah. Thinking back to the ejecta from comets, I vividly remember Hale-Bopp looking through my telescope because it was spinning and because the points where it was ejecting matter were going with the spin. It was like looking at a lawn sprinkler from the top.
That's
Wow.
telescope. Yeah.
It was going, and you'd see that in an evening because it was rotating fast enough. You could see it going round and round and round.
Wow.
It was amazing.
It's cool. So I don't know if you saw Miles' comment that just came up there. That is a final score.
What is?
4-3.
For
what?
Toronto.
Guess who?
That happened while you were expostulating.
Okay, I'm going to cede the floor to Natasha, and then let's see how things go.
Okay, I'm going to share my screen. Just going to move some of these things out of the way. All right.
All good.
Thank you. Thank you very much. That was interesting too, Randy. I hadn't been following that story, but I learned a lot. So over the years, I've traveled to India about 3 or 4 times, and the furthest north I've ever been has been Sikkim. So I was really interested to see a couple of news articles last month about the Dark Sky Reserve in Hanle in Ldakh. I don't know if any of you have been up there or have followed it, but here's a map just showing you the location. So it's very far northern India, a very hot geopolitical zone close to the border of Tibet. And here is Nepal down in the lower right corner. So I hope you get a sense of its location. So it's being called a sustainable development project. It includes a region of roughly 22 kilometers radius inside the Chantang Wildlife Reserve, and it was declared as the Hanle Dark Sky Reserve in December of 2022. And it's the first dark sky reserve in India, and it's being operated through a memorandum of understanding amongst 3 or 4 different organizations. So the Himalayan Chandra telescope is there for several years now. It was identified Hanle's location conditions as being ideal. So the Himalayan Chandra telescope opened in 2000, followed by MACE, which I have a slide about later if anyone's interested. That's the world's second largest gamma ray telescope. Now I'm going to try and show this video. I'm going to have to stop sharing this presentation and sharing, sharing another screen. Okay. Hopefully this works.
missing the sound.
Yeah.
Highest motorcycle.
Moon.
Oh, there are quite a few videos.
Okay.
Very cool.
Mm-hmm.
Yeah, thanks, Natasha.
I've still got the other
You
video
still got one
going.
more thing. Yeah. Not
Oh, we have
quite
some
yet.
background music. I don't know if you can hear it. So, anyways, it's rated 1 on the Bortle dark sky scale. It's up at 5,290 meters, a moon-like landscape. And I wasn't familiar with the Bortle dark sky scale, but it's a number 1. And there's quite a few things that the observatory has already contributed to. And oh, this is the Bortle, so it's number 1 here. What I liked about the story is that they're engaging the local villagers. There's 24 locals who were selected and trained as astronomy ambassadors. They're all relatively young, and 2/3 are women. So each ambassador was given an 8-inch telescope and trained to operate them, and they now function as the astro-tourism guides. Here's some information if you go. I know there's some political difficulties there right now, but they're saying that the best time to go is between May and September. There's a little hotel there. That's a picture of the hotel. And I think it'd be a fantastic trip to be able to make. And so, yeah, that's the story.
Yeah.
Very good.
Are you tempted, Natasha?
I'm sorry?
Are you tempted? Are you going?
I am tempted to go for sure. It's 17,000 feet. I mean, the last time I was living in that altitude was quite a while ago, so it would take a bit of acclimatization, but I think it would be a fantastic trip. Yes.
Yeah, especially for those of us who were sea level dwellers. That's a massive change. Yeah, yeah.
For a bunch of.
Yeah.
Do any of you know anyone who's been up there?
That's 500 millibars. That's half the atmosphere.
Yeah. Wow. Quite a challenge.
Natasha, do we have anything that's one Bortle, like around us at all?
I don't know. I was going to ask.
You know,
Does anyone
that
know?
area reminds me very much of the Atacama Desert.
Yeah.
Same topography, and although it's even more extreme altitude, of course. And
Yeah.
as an aside, of course, the Atacama Desert residents are now complaining about light pollution. So
Yeah, border
there you go.
border one is very rare.
Border one is amazing.
When I was at Kit Peak, they used to boast that they were even one or two, but they certainly aren't that now. So that would probably one better it.
They have 270 clear nights a year.
Yes, that's impressive.
That's because it's more than we guessed, you know.
Yeah.
If it's so good, why are they not putting more major telescopes up there? It's not like everybody talks about
Politics.
Hawaii and the
Yeah,
Canaries.
I would say Joe's hit the nail on the head. Politics.
Yeah,
Oh,
it's a very
If you could
hot.
dial China out of the way, you'd be probably not too bad, but not going to happen.
because of politics.
I
Yeah.
would think that the mountain structure might introduce a lot of turbulence. Maybe the scene is not as good as that.
Oh, yeah.
Moment here.
Yeah. But very interesting. Yeah, who knew that was there? I didn't. So thank you for bringing that to our attention.
You're welcome. Thank you.
That was good territory.
Yeah. Okay, so we're doing well with the time. Chris Gainor, do you have you survived enough to say something? Are you still there? You are. Yeah, you're still here.
I will just give a brief update about what is and what isn't going on at NASA. Actually, one of the features of the International Astronautical Congress that I I attend this every 10 years, whether I need to or not, even though it's an annual thing. And they always have an event with the heads of the space agencies. And I must say that this year that feature was rather boring. The only head of a space agency that had anything to say was our own Canadian head, who was announcing some funding for things. But the acting head of NASA showed up, somewhat to my surprise, because Sean Duffy is his name, and he's also the head of the Department of Transportation. And he has a background as a host on Fox TV, and I won't get into that any further. Anyway, everybody was kind of walking on eggshells, and he was saying nice things about how they want to go to the moon. I may talk about that when I give a fuller presentation. So anyway, just in brief, the situation right now is that we were hoping for some clarity about what was going on with NASA at the beginning of October, when the fiscal year starts in the States. Don't ask me why it's that date, but over the years it's kind of moved back in the year. But as you know, on October, or as most people know, on October 1st, the government shut down because the Congress couldn't reach agreement on things. So we are basically waiting for that to be resolved. And there has been talk that cuts would be made during this time, or that things would change. But it's just kind of unclear. But I thought I would just bring your attention to a report from the Planetary Society. Let me see, just let me find that. So there have been a lot of cutbacks as things stand. In their most recent newsletter, the Planetary Society says that the Jet Propulsion Laboratory, which is in the planetary exploration business, has laid off 550 people, which is about 11% of the lab's remaining workforce. On a happier note, there was rumors that the Osiris Apex mission, which is kind of the successor to the Osiris Rex, which got the sample, but you still have a functioning spacecraft, was going to be going around the asteroids. That apparently has been saved. But yeah, that the JPL number comes in the amongst other cutbacks at NASA. About 4,000 NASA employees, or 20% of the agency, have left in the last 6 months. So there's cause for concern, but there is a very interesting and somewhat surprising development over the last few days. So Sean Duffy is in this position in a temporary situation, although apparently he enjoys being a NASA administrator more than being Secretary of Transportation. But you might recall that earlier in the year they had nominated and were almost set to install Jarek Isaacman in as NASA administrator, and he's a billionaire who's funded some SpaceX missions, and he's flown on 2 of them. He's also fairly well respected and popular in the space community, but he is known to have he's not known as a really big MAGA person. Not that he's against what President Trump is doing, but that's not his thing. And he has contributed to Democrats. So he was, just before he was going to be put in as administrator, having gone through the Senate process, his nomination was withdrawn because some of the more MAGA types in the White House got to the president and talked him out of proceeding with that. Now, since then, Isaacman, as is his wont, has been very low key and, wasn't upset or didn't go trash talking. And now there's rumors flying around that he is under consideration again, that he may wind up being the administrator, which I think most people would think would be a good thing. But that's still up in the air. And just before this meeting started, there was I read a big article about an announcement from Sean Duffy that just came down today, or yesterday or today, that they are looking a bit more widely than SpaceX or even Blue Origin to build a lunar module for Artemis 3, which is supposed to be the first American landing on the moon since Apollo. So we're going to have to see what that all means. Right now, the prime contractor for that is SpaceX. But Elon Musk is so focused on Mars that he's been kind of ragging the puck with this lunar goal. And there's a concern in the U.S. that the next voice we'll hear from the moon will be speaking Mandarin. So anyway, I just thought that's just kind of the situation. Lots of balls are up in the air. And right now, of course, we're looking forward to Artemis 2, which will have a Canadian on board, which will go around the moon as early as February. And that's the situation right now. So we'll see how things go, and in a week or two, when we have the schedule and I get this thing done, I'll give a little presentation about some of my activities in Australia.
Thank you. Yeah.
Thank you.
Okay. Maybe we should. Margie raised a hand. Okay, Margie.
Chris, I have looked at the APOD for every day for the last 8 years. So when it disappeared on October the 2nd, I was pretty disappointed. Has it disappeared because of cutbacks or government not operating?
That would be because of the government shutdown, which is ongoing, and both sides in that think that they can win, so it's going to go on for some time yet. Yeah, lots of things get caught up in it. I remember when I was working on my first book back in the 90s, and Bill Clinton and Newt Gingrich decided to go after each other, and there was a shutdown, and it almost ruined the research for my book because I was down there doing stuff. I did miss some stuff, but the day before the really crucial stuff was about to get underway for my research, they finally ended it. So I was able to do that research.
Lauri.
I was just going to say, if you go to NASA, it'll just say nothing has been updated and there's nothing happening. So there's been no updates to any of the websites for anything under NASA since the shutdown. That's the banner at the very top of it is all that. So nothing's happening there, or not in that way for the website.
Mm-hmm. Reg.
I just wanted to mention that the Juno spacecraft that's been orbiting Jupiter since 2016, its last extension expired during the shutdown. So we don't know if it's been re-extended or not, but it's already gone through 73 orbits, and it was initially planned to have 33 orbits. And it was supposed to end its mission in 2018. So it's really done very well, and it's near the end. I think it's having technical problems everywhere.
Yeah. Thank you for that update. Maybe we should pause for announcements.
Absolutely. Yeah.
So I believe there's a council meeting tomorrow night, correct?
Mm-hmm.
Some of the council members are nodding, yes. So the link went out for that. Anything else happening this week? Any of the SIGs?
The astrophotography SIG was delayed till next week.
Okay,
So it's
so
normally this Wednesday, but it'll be next Wednesday.
Okay, and Lauri.
Yep, there's the annual meeting of the Friends of the Dominion Astrophysical Observatory is on Saturday, and I'm thinking that it doesn't look like it particularly great weather, but if people are interested in coming out, we'd love to have you, and we can always have somebody out on the front desk for the welcome desk, and even if it's not terribly great outside, we can be showing some of the telescopes inside in the lobby, and it's always really nice to have people inside, especially when the outside is not very good. We always can use other people inside to be talking about things in the gallery, or chatting up to visitors about telescopes and all that kind of thing. So we'd love to have you up. No problem at all. So thanks very much. The only other thing I was going, again, I've already put in for calendars, and I think I have about 5 more left. If anybody wants a calendar from the RASC National, give me a give me an email. And I have not put in the order yet for the workbooks and that kind of thing. But that's going to be coming soon. So if there's anybody else just right here that wants to, just let me know. I can put your name in for one of the calendars. They're going fast, so there won't be any left this year. So just so let me know. And I think that's about it. Thanks.
Thank you, Lauri. Does anybody else have anything?
Well, I would be pleased to do one last thing.
Sure.
So let's go. Oh my, where's my share? There's my share. And here. So first of all, in case you don't know, James D. Francesco, who heads the Hartsburg Astronomical, help me, he's the director of the observatory here, and he puts out an almost daily newsletter, which you can get on his mailing list, and they're delightful. Anyway, today he decided to talk about the comets that are visible. They're just around, naked eye visible. And in particular, he shows off the picture of our RASC Victoria Center colleague, Stephen Martin, whom I'm afraid I don't know, but he put out this beautiful picture of Comet Lemmon, which is in the northwest, quite low, underneath the handle of the Big Dipper. And this picture was making the rounds in the emails. It's absolutely spectacular. Anyway, I decided last night to give it a try. And I want to show you that, but for some reason, there we go. So this is what you see with stellarium. These funny creatures here. That's that. What's the Canis
Vanatici?
Vanatici.
Yeah.
Okay.
They're
Anyway,
hunting dogs.
These are these hunting dogs here. That two tails there and a head. Anyway, so this is my north window, and I thought it was more north than northwest. So my camera's at a pretty oblique angle. This is a terrible observatory, and the worst thing is I live close to here, so I have to look over the light dome of Victoria to see something. And seriously, I could see Capella, but I could see hardly no other stars. But I decided to give it a go because there was very few clouds. And so with the tracker and a 30-second exposure and then ramping up the contrast, can actually see a bunch of stars. I thought it was going to be kind of in the middle here, but then matching the stars to the stellarium, it was way over here, just next to the where the roof cut it off. So here we are. Do you see?
Uh-huh.
And here it is blown up. There's the little nucleus, and there's a tail there. That's what I can do.
That's not Portal 1 then.
No, two dozen.
But I was hoping that some other people have had a chance, either visual or with a camera, to have seen any. Is that Comet and also Comet SWAN? Has anybody had any chance?
Yeah, we've seen it a couple of times actually. Once up at the VCO, I think Wyman was able to see it in his binos, and as you well know, when we were out doing that test run for Saturn. I think the comet was also spotted then too.
Oh, you could see it that night. Great.
Yes.
At the VCO, I think about 7 different scopes were able to see it.
Oh, that's awesome.
But we had a festive and raucous time up there watching this. But it's really far better to see it in there than say after 3 or 4 in the morning, looking to the northeast. And I've taken photos of it when it was at an altitude of about 20 degrees above the horizon, and it's very good at that time. The only thing is,
So it sets at 9 or so. It comes up again.
It comes up again. It rises around 1 in the morning, but it's really in the murk until about 3 or 4. And then, but Randy's moon was causing problems with it.
Ah, yeah. Well, I don't worry this week if it. It's okay at 4 in the morning.
It's beautiful. Yeah.
Mm-hmm.
Well, it just to curb your enthusiasm, it's not very big, and it's fairly faint.
Yeah.
But it is quite satisfying to see it. So it's worth a try. But clear skies are clear.
Randy,
Clear skies this week.
Tomorrow evening may be a little bit better than the rest of the week, but it looks like we're pretty much.
So Randy, starting tomorrow, we might be able to catch SWAN. Actually, if I do a share, I'll show you where it is.
Yeah. Last item.
So there it is. I think I mentioned this a couple of weeks ago. It's quite easy to find. There's Altair right there, and this is Capricorn, and there's these beautiful set of optical doubles here, Algidi, Prima, and Secunda, and it's quite close to there actually.
Okay. So who knows, but probably not. Maybe not this week.
Maybe tomorrow if it's clear.
Maybe tomorrow if there's enough clearing.
I clearly heard David say it's going to be easy to find.
Yeah, it should be.
Well, it's got something near it, so that should help.
Yeah, I mean, if you find Capricorn, the Algidi is worth looking at anyways. It's a beautiful optical double. And then, of course, Altair is easy to find.
Yeah.
If you want to cheat, you can go to the, we talked about them shortly, website, and it gives you the RA and deck.
Yeah, you could do that too. And
and dial it in. Yeah.
I'm actually thinking of bino viewers, like people that want to use their binos or something like that.
Can I just mention that Steve Martin's shot was taken with a C star?
Yeah.
Yeah.
And he had it up the hill, and he was having way too much fun with it.
Yeah.
Just a very impressive device, and the feature is here today.
Yeah, that's what I was going to say.
They're really becoming popular, those things.
Yeah.
I talked to him. I already said I wanted to see how it worked.
Yeah. So maybe we'll have some chat about that in the future, how those work. And maybe somebody who owns one can tell us more about what they've done with them.
I think there's a lot of members with smart telescopes now, more than you would think.
I'll be talking about the smart scopes in about a month.
Oh, perfect. Yeah. Okay. Well, any final comments? Because we need to return the room.
Yeah, the request. Reg is the next host on the 27th. And let's have some better pictures of comets than what I produced.
Well, there may not be time to get them between now and then, but let's fingers crossed.
Yeah.
Right? Okay, so reminder, council meeting tomorrow night, FDAO AGM on the weekend, and I think that's it for this week. So thank you everyone for joining us, and thank you to the presenters, and we'll see you next week.
Welcome back.
Thanks to Kathy and Elaine for coffee.
Yeah.
Thank you.
Thanks, everybody.
Yep. Good night.